The algorithms shaping our world, from AI recommendations to critical geopolitical analyses and multi-billion-dollar hiring decisions, are built on vast amounts of data. But what if the most crucial insights, the patterns that could expose systemic biases, predict market shifts, or even reveal unforeseen vulnerabilities, are hiding in plain sight? What if they are trapped within categories, not numbers, creating dangerous blind spots in our understanding of reality, and leading us to incomplete conclusions? For too long, our data analysis has been fixated on the quantifiable: averages, regressions, standard deviations. We construct elaborate models based on numerical inputs. However, this numerical obsession often overlooks an equally vital landscape. Human behavior, consumer choices, social media trends, and even the geopolitical allegiances of nations are fundamentally driven by categorical distinctions: yes or no, male or female, platform A or B, ally or adversary. These are rich, non-numerical dimensions that traditional statistical methods often fail to fully grasp, leaving critical gaps. This is precisely where the Chi-Squared test steps in, a quiet but incredibly powerful analytical tool for navigating the complex world of non-numerical data. It is not about calculating averages. It is about discerning patterns and relationships within discrete groups. This statistical powerhouse is designed to uncover distributions and associations between categorical variables, revealing the hidden dynamics and unexpected connections that simple numerical summaries can never illuminate. It is an indispensable addition to any serious data scientist's arsenal. One primary, deeply relevant application of the Chi-Squared test is the goodness of fit analysis. Imagine you have a preconceived notion or a specific hypothesis about how data should be distributed across various categories. Perhaps a fair representation across different demographic groups, or an expected market share for competing products. The goodness of fit test rigorously evaluates whether your observed data statistically aligns with that expected pattern, or if there is a significant, underlying discrepancy suggesting a deviation from your initial assumptions. Consider the intense scrutiny surrounding AI bias, a truly pressing global concern. Is an AI-powered recruitment system, lauded for its efficiency, truly distributing job interview invitations or offers fairly across different ethnic or gender categories, as mandated by ethical guidelines and regulatory bodies? Or is there a subtle, statistically significant imbalance against certain groups, indicating a deeply embedded, historical bias within its training data? The Chi-Squared goodness of fit test can precisely expose these disparities, revealing if observed higher rates align with expected fair proportions. Moving beyond single distributions, the second, perhaps even more intriguing use of the Chi-Squared test is the test of independence. This is where we delve into the question of association. Are two distinct categorical variables linked in some meaningful way, or do they operate entirely independently of one another? Are the choices people make on a new social media platform independent of their age bracket or geographic region, or is there a compelling, unseen connection driving their interactions? Unmasking these connections can reshape our understanding of user behavior and market forces. Let's apply this to the current, volatile landscape of social media and global events. During a major geopolitical crisis, are specific types of viral content, perhaps narratives pushing a particular political agenda or even sophisticated deepfakes, disproportionately engaged with by certain ideological groups, or by users from particular nations? The Chi-Squared test of independence can reveal if there's a statistically significant association between content type and user group, potentially unmasking coordinated influence operations, the formation of dangerous echo chambers, or the effectiveness of targeted disinformation campaigns that are shaping public opinion. At the fundamental core of both Chi-Squared tests lies the concept of the null hypothesis. This is our default starting assumption, that there is no meaningful difference in distribution, or crucially, no statistical relationship or association between the categorical variables we are examining. The Chi-Squared test then becomes our rigorous statistical arbiter, providing the empirical evidence to either confidently uphold this initial assumption or, more often, to compel us to reject it, forcing us to confront a new and often surprising reality about the patterns within our data. The test quantifies this discrepancy through the Chi-Squared statistic itself, which is calculated using the formula \2 e_I. Here, \ meticulously represents the observed frequency or actual counts within each specific category, while \ signifies the expected frequency or counts that we would anticipate under the assumption of the null hypothesis. Critically, a larger calculated \ value inherently suggests a greater and more pronounced divergence between what we actually observe and what we initially expected. This calculated chi-squared statistic, when considered alongside its degrees of freedom, ultimately leads us to a crucial p-value. A low p-value, typically falling below a conventional threshold like 0.05, serves as our powerful statistical signal. It indicates that the observed patterns, the very discrepancies or associations we have uncovered, are highly unlikely to have occurred simply by random chance alone. When this happens, we are statistically compelled to reject the null hypothesis, unequivocally acknowledging a significant deviation from expectation or a robust, underlying relationship between our categorical variables. This is when new insights emerge. The profound implications of these findings are simply enormous, reverberating across geopolitics, economic policy, technological development, and even public health. From identifying deeply ingrained systemic biases in critical AI systems that make life-altering decisions, to understanding complex consumer behavior in volatile and unpredictable markets, or even predicting shifts in voter sentiment based on nuanced demographic categories, chi-squared tests offer an unparalleled lens. They empower leaders and analysts to truly navigate an increasingly categorical world, revealing surprising consequences and exposing hidden power dynamics. In an era utterly defined by the relentless pursuit of data-driven insights, willfully overlooking the profound insights offered by categorical analysis is not merely a statistical oversight, it is a critical strategic blunder. Mastering chi-squared tests transcends being just another statistical skill. It is an indispensable tool for anyone striving to truly comprehend the hidden forces shaping our digital landscapes, our economies, and our very societies. It empowers better, more informed decisions in a world brimming with complex, non-numerical patterns, ensuring we see the whole picture, not just the numbers.